Okay, so my second problem is 61, and it says astronauts in space weigh themselves by oscillating on a spring. Suppose the position of the oscillating 75-kilogram astronaut is given by x equals 0.3 meters multiplied by the sine of pi radians per second time, where time is in seconds. What force does the spring exert on the astronaut at 1 second and then 1.5 seconds? So it gives us a position equation, and these t's should be within the sine and cosines. It gives us our position equation, and we can find our acceleration by taking the derivative twice. So the first derivative of position will give us velocity, and then the first derivative of velocity will give us acceleration. So we're able to find that our acceleration equation will equal negative coming from the derivative of cosine. So we have negative 0.3 meters multiplied by pi squared, because you have your chain rule within taking the derivative of your sine and cosines. And then your t is what you're taking derivative relative to. So it's just going to stay as the t within the sines. So for your 1 second, you're going to be able to plug in 75 kilograms for your mass using the F equals ma equation. And then you have your 0.3 pi squared meters, and then your 1 pi within the sine, which sine of pi is just going to be 0. Whereas if you plug it in your calculator and you're in degree mode, you're going to need to plug in sine of 180 to make sure that you're using the right mode for your calculator. But if you're in radian mode, then leaving it in pi will be okay. And then for 1.5 seconds, you have your F equaling ma still, and you're using, the only thing you're changing is the time within your sine. So you just plug in 1.5 for your time instead of 1, and your sine of 1.5 radians will just be 1.5 times 180 will get you 222 newtons.